Okay, time for problem 7. The diagram shows part of the graph of y equals first derivative of f. Okay, so this is a first derivative. The x-intercepts are a and c. There's a minimum at b and a maximum at d. Okay, so since this is a first derivative, I know that a and c are going to have the x-coordinates of the maximum and minimums. And since this is a first derivative, this tells me about the slopes of the original function. So let's go ahead and see what the questions ask us. All right, write down the value of f prime of x at c. Here's c. It says the first derivative. This is the first derivative. When it says value, they're talking about y. What is y? So at c, what is y? It is 0. Okay, so f prime of c is equal to 0. I don't know. Do I want to say f prime of c, or do I just want to write the value is 0? Let's see. I don't know, because we don't. Is that going to be our x-coordinate in c? Like it's c comma 0? That's one way of writing it. I don't know. If you had just written 0, that would be fine. Okay. Hence, show that c corresponds to a minimum on the graph of f, i.e. it has the same x-coordinate. Okay. So how do I know this is going to be a minimum? Well, if I make my sign diagram, I like sign diagrams for this, at c, if I look at my values, my function values before c, I have negative function values, and afterwards I have positive function values. So this is the sign diagram of the first derivative. So remember, these tell me the slope of the original function. So on the original graph of f, I have a negative slope, and then I have a positive slope. So I have on the original function, I would have a negative slope coming into point C. It would then go tangent, it would have a slope of 0, and then it would go back up with a positive slope. So therefore, C is a minimum. So how do I know C corresponds to a minimum? Because the slope is negative to the right and positive to the left. Yeah, something like that. So anyway, I've sort of, I made my sign diagram. I showed this is my negative slope and my positive slope. That's another way I could have done it. And I could have written it out in words. Okay, so a bunch of stuff going on there. Somehow justifying why I know that it's a minimum. All right, which of the points, A, B, or D, corresponds to a maximum, on the graph of f, the original function? Okay, so it's tempting to say D is a maximum because it looks tall, but this is the derivative. It is not the original function. So remember, the original function, we take the max and mins, and those become x-intercepts on the first derivative. Okay, so this is first derivative. So A and C are my stationary points. These are my stationary points. They're the ones that have a slope of 0 on the original function. So my only choice here is A or C. And notice C is not a choice because we already know it's a minimum. So therefore it must be A. Which one is the maximum? It would be A. Okay, and we could make a little sign diagram. Here's my f prime of x. We have at A and C, here's my A and here's my C. I have positive function values, negative function values, positive function values. So how does that relate to the original graph? It relates that I have a positive slope of 0, and then a negative slope. So therefore, point A is a maximum. Okay, show that B corresponds to a point of inflection. So from my first derivative, this is my first derivative, I can find the second derivative. So the second derivative, f double prime of x, is I take the maximum and minimums of my first derivative, and they become my x-intercepts. So I'd have B, and I'd have D, and then I look at the slopes. Okay, so this has a negative slope, and then from B up to D, I have a positive slope, and then after D, I have a negative slope. Show that B corresponds to a point of inflection on the graph of F. So I'm changing from concave down to concave up. Okay, so because B is an x-intercept on the second derivative, I'm changing from concave down to concave up. Okay, so changes from concave down to concave up at point B, B, therefore it's an inflection point. Okay, so let's see, could we describe it another way? It's changing from, no, I think that's the easiest way to describe it. Okay, so that's problem 7. All right, so I'm using my sign diagrams on this one to help me out. Okay, sign diagrams.